Welcome to my presentation on solids of revolution. A solid of revolution is a three-dimensional solid that is formed when a curve is rotated around a straight line. The process for finding the volume of the shape is similar to finding the area under this curve. When finding the area, we used a typical rectangle, whose length was equal to f of x and width was equal to delta x. If we rotate this typical rectangle around the axis, we'll form a cylinder whose volume equals pi radius squared times height, where the radius equals f of x and the height equals delta x. We then take the integral of this formula to find the volumes of all cylinders within our region. This will give us the volume of our solid. When finding the volume of a shape rotated around the y-axis, we simply use f of y as the radius and dy as the height. So the first thing we do is find x in terms of y. We then solve it like any other problem. This problem uses the washer method because the typical rectangle forms a washer when rotated around the axis. This method is used when the typical rectangle is not flush with the axis. To solve this problem, we subtract the volume formed by the inner radius from the volume formed by the outer radius. To solve this problem, I used the shell method. In this method, the typical rectangle is parallel to the axis, so that it forms a shell-like shape as it's rotated. Think of this shell as a long rectangular box, which has been curved to form a circle. The length of this box is the circumference of the circle it forms. The height is f of x, and the thickness is delta x.